All right, let's take a look at acceleration. So we've done a little looking at our three different kind of pieces up above, and that is our conversion of velocity initial to velocity initial in the physics or the kind of regular world, and then in our stop motion animation, and then our final, and the amount of frames that kind of is going to take. And we put those down below in our timeline. But let's look at acceleration now to see if we can figure this out. Acceleration is simply a rate of change of how quickly our velocity is changing over time. And this is our equation that comes into it. So to think about how quickly our velocity is changing, we need to think about, well, what does a change in velocity look like? So I'm going to go ahead and write that in right here, kind of looking as it is. So I'm going to say my acceleration is equal to, right, a change in velocity that is happening over a certain amount of time. Now, when we have a change in velocity, we need to look at kind of how things start and how they end. And to figure out a change in, we actually subtract the starting point from the ending point. If you can think for just a moment about, I was thinking about how tall I am and how much I've grown over a certain amount of time, then I would say, well, how much was I before? How much am I now? And to figure out the difference between those two things, I would subtract the first one from the second one. I'm going to do the exact same thing here when it comes to velocity, where I'm going to say, hey, what is my kind of velocity final? Let me go and erase that for a second. So I'm going to say velocity final minus my velocity initial, right? And I'm going to put that over the top of a change in time, which is a time final minus a time initial, right? So this is my change in velocity over change in time. And my change in velocity goes like this, where I say my final velocity is going to be 1 centimeter per frame. Again, I'm talking about this in terms of stop motion animation. So I'm going to subtract now my starting, which is 0 centimeters per frame, right? And then I'm going to divide that whole thing by the amount of time that passes, where t kind of I, my initial is 0, and then tf is my final, which is a total of 15 frames, which is what we found earlier. Now, what I have noticed over the years of teaching physics is that the math that we're doing is not tremendously difficult math, but because of the fact that suddenly we've got all of these units in here crowding everything out, it makes everything look a lot harder than it really is. For instance, if I was to just pull the numbers out of here, almost nobody in our group would be able to say, oh no, that looks hard, because all I'm getting is 1 minus 0 divided by 15. Right, and that doesn't seem so bad. 1 minus 0 divided by 15, that seems reasonable. And 1 minus 0 over 15 is nothing more than 1 over 15, right? And 1 over 15 we could do on a calculator if we wanted to. So 1 divided by 15. And the answer to that is this number here, 0.067. Right, 1 over 15, 0.067. So how do I know that this is 15? I knew that was 15 from this number up above as 15 frames. I know that my change in velocity, right, is going from 0 centimeters per frame to 1 centimeter per frame as we're looking at it. Those are speeds or velocities in this case. And then I divide these two things out and I get 1 over 15, which is 0.067. All right, so there it is. And if I go down below into this scene timeline and I put this in, turns out this 0.067 is actually the number that is the same all the way down. Why do I know that? Well, at least for 15 frames, right? All the way up until here as we're coming into it. I know that because it's speeding up the entire time. And this number right here is the amount that it speeds up every frame. So 0.067 is here and 0.067 is there and so on. All the way down but this takes a really long time to write. So I'm just going to go ahead and say, hey, all of these numbers all the way down here to frame 15, all those numbers all the way down are the same number here, which is how much we speed up every frame. Right? So which means that if we start at 0 centimeters per frame and I speed up by 0.067, then if I'm speeding up by that amount, then the next number here is 0.067, right? Because I've sped up by 0.067, so therefore I'm now in this 1 centimeters per frame. And then if I speed up by another 0.067, I'm just adding on this new amount to it, which is kind of doubling it at this point, but it won't be doubling it as we go. So 0.067 plus 0.067 is 0. Well, it's about 1.3 if we want to get there close. And if we continue this process, then we end up with 0.197 about, and so on as we go if we're adding on another one. So we just keep adding on the 0.067. Each time I'm just adding on the amount that we increase our velocity by, which is our acceleration. Off it goes. Over here, this is the culprit. We're going to take a look at how we figure out how the position changes next. So here we go. We're just adding 0.067. This number stays the same all the way down. The next thing we're going to do is take a look at how position changes, and that'll be in the next video. All right, we'll take a look there. See you in the next one.